Hello again, on to page 2 of today's notes. So we have two sets of parametric equations, kind of like the other side, and we want to find the minimum distance between them. And here's the distance formula. This is going to be very similar to the optimization that you guys did earlier on in the year. So we're just going to use the distance formula, plug in these values into that formula, and this gives you the distance between the parametric equations. So going to be really long. The distance x1, we'll call this x1, y1, x2, y2. So x1 would be 35 cosine 45t minus 50 minus 30 cosine 40 t, close parentheses. This parenthesis closes that one. Now we need one more parenthesis to close the bigger one and square it. Now for this next part, I'm going to kind of take a leap here that you can understand what's happening, but if we do this minus this, what ends up happening is the negative 16t squareds would cancel out, the 3's would cancel out, and we'd be left with 35 sine 45 t minus 30 sine 40 t. Square that. So the distance ends up being pretty long. Formula there. So here is the equation. I already substituted it. I simplified it a tiny bit and put it into my graphing calculator under y equals. I then use this window. So if you want to pause now, you can put that in your window. And this is what the graph ends up looking like. So to find the minimum distance, it would be this value right there. I'm going to go to second calc. I'm going to go to minimum, slide to the left, hit enter, slide to the right, enter, and guess right there. And the answer is 1.034 for the time value. This question is asking for the distance though, so that's going to be the y value, 5.688 units. So if this had been a problem where two people were throwing a ball to each other, this would have been 5.68 feet is the closest the balls come over the time. Okay, let's go to this next one right here. It's a slight complication with the second problem. So will a ball clear 15 feet wall that is 300 feet away? So 15 feet wall, that is a y value, 300 feet away is an x value. So the parametric equations for the x would be 300 is equal to initial speed of 120. So this would be 120 cosine 23 times time. That's for the x equation. Now for the y equation, 15 equals negative 16t squared plus 120 sine 23t, and then plus 4. So what we would do here is we would solve for this time in the calculator. So we get a t equals for that, and then we'd plug the time into this to see how high it is. So let's find out what happens. I'm going to do 300 divided by, be careful about parentheses here, parentheses 120 cos 23. I get 2.716. Let's see how high it is at 2.716. Is it above or below 15? Negative 16 times that squared plus 120 sine 23 times this guy again plus 4. We get 13.32 feet. Oh man, It's going to hit off the wall. That is so close to being a home run. Okay. Now, in this case, assume at the moment the ball is hit, there's a wind gust of 10 feet per second. So if you can imagine a ball being hit in the air, like this, here's the baseball, it's getting hit up in the air, but there's a wind going directly this direction against Oliver. What's happening here is that this wind is only impacting the X component because it's going in a directly horizontal direction. The Y value will not be impacted by this because the height doesn't change based on a wind coming directly horizontally. However, the ball will not make it as far as it would have with no wind. So the equation is going to be 300 again equals, and this is where it gets a little complicated. It starts off the same, 120 cosine 23. However, this right here is the horizontal speed of the baseball. So if there's a wind blowing 10 feet per second directly against it, that is going to directly impact the horizontal speed of the baseball. So we actually subtract 10 from that speed value and multiply that by t, just like we would have in the previous problem. The y equation is exactly the same, negative 16t squared plus 120 sine 23t plus 4. So the process here is the same. You would find out this t value, plug it in. Since it wasn't a home run originally, it won't be a home run if there's a wind in the face of Oliver. But you can certainly try it out if you want to. I hope you enjoyed the video, and good luck with the rest of the assignment.